Okay, we're live. So it is March 5th, 2015, 11 a.m. Pacific, and this is DB Hangops. Today we're going to be talking about group replication, multi-threaded replication. If we have time, operational learnings with GTIDs, and maybe some more stuff about 5.7 default changes that Morgan's been working on with the community. So let's do a quick round of introductions. I'm Jeff Anderson. I'm a DBA at Box. Daniel, do you want to go ahead?
Okay, I'm Daniel. I'm a DBA at Snow.
Okay, Morgan? Oh, Morgan, I think your mic might be broken.
Yeah.
Let's go to Shlomi then.
Hi, I'm Shlomi. I'm engineer at Booking.com.
Okay, and Pim?
Hi, my name is Pim Vanderbal. I'm a DBA at Acquia.
Okay, do you want to try again, Morgan? No dice. Okay. And last is Nuno, who is our guest speaker today. Which looks like he just got muted.
Jeff, are you having an earthquake?
No, I'm moving my laptop around a bunch. Nuno, can you hear us?
So, hello, this is Nuno.
Oh, perfect. Okay, well, go ahead and take it away, Nuno, and tell us about group replication, and I'll set you to be presenting for everybody.
Okay, so hello everybody, let me just switch to full screen. So, can you see my presentation okay?
Yep.
Okay.
No, not screen effects.
So, can you hear me now?
Yep, we're good.
Okay. So, I want... Yes, I'm hearing you. So, okay, someone is... Can you hear me now?
We can hear you.
Okay. So, someone is muting me, so please don't do that. Yes, okay, so my name is Nuno Carvalho. I'm one of the replication team developers from MySQL, and I'm going to present a small feature set of MySQL group replication. So first thing first, safe harbor statements. You all know that, so let's move forward. So are you listening to my voice in real time or with a big delay?
By laws of nature, we don't know.
Okay, something is...
Okay, looks like Nuno just dropped out, so we'll see if he comes back and has a better connection going. I guess while we wait, Morgan, do you want to give, is your mic working now? Do you want to give a quick intro? Morgan's mic is still broken.
It's going to be one of those hangouts.
Okay, looks like Nuno's back. Can you hear us, Nuno?
Hello. So hello again. No. So, can you hear me in real time or not?
I
I
think we
assume
can
not.
hear you.
Right?
It does seem like there's a little bit of a delay.
Yes, so, okay. Let me try again. Sorry.
Okay, no problem. I guess while we're waiting for everything to sort out, I think Morgan's working now.
Am I?
Yes, you are. So while we wait, let's see. Looks like Nuno is getting his stuff set up. So Nuno, do you think you want to just kind of go with it, and we'll chime in through chat with questions?
So can you please say what do you see on the screen?
Yeah, we can see the program agenda. It's not full screen, but it's readable, and I think you can just go with it.
Okay, I'm listening my voice with a really long delay, but so well, let's move forward. Okay.
Oh, we lost him again.
Okay, what's on the agenda today? We have binlog group replication, parallel replication, readable, and I think you can just go with it.
And we have Jean-Francois.
Yeah, you know what? Let's do a rearrangement of the schedule and start with parallel replication, just because JF just got in and he has a lot of experience having experimented and investigated this a lot. So we can maybe start with this and then move back to group replication.
Sounds good to me.
Sounds perfect.
Cool.
Go ahead. Does he know what we just signed him up for?
Okay, who wants to begin? So, MySQL 5.7 and MariaDB, if I'm not mistaken, support true parallel replication, which means it's a replication not based by schema, but by just general queries running together. These queries are being grouped together in the binary logs through group commit. These queries are these are transactions that are being executed concurrently on the master and do not interfere with one another, so they do not compete for the same logs, etc. Such queries could be grouped together, written to the binary logs, then interpreted by the slaves, the slave being able to realize that these transactions are all in the same group, they do not collide, they could actually be executed again in parallel, thereby allowing for multi-cores execution on slaves. That's the general that's the general overview of the things. Morgan?
Hello.
No, I think that's a pretty good description. The interesting thing is that Nuno probably share some detail on that as well if we can get his audio to work. The part that I like highlighting when I describe it to people is the parallel applier on the slave uses the metadata from the master of that commit time information, and that's the kind of catch that is kind of useful to know that. And so we've gone through iterations in 5.7 of trying to improve our algorithm of how we're recording that information of parallel commit.
So is this specifically something that comes with 5.7 now? Because I like parallel replication was kind of the new hotness when 5.6 was announced, and we've turned it on in a few like isolated cases internally here. But I'm wondering, like, what are there like some noticeable changes in 5.7 that make it a lot better than it currently is, or?
I think Shlomi described it pretty well. I hadn't heard it described that way before. where he called it true parallel replication. We describe it officially as intra-schema parallel, where within your MySQL database, within that, we'll be able to replicate that in multiple threads on the slave.
The statements inside the same schema can actually be executed in parallel as well.
That's right. That's right. In 5.6, it was just individual schemas on a different schema basis. We could apply that in parallel.
Right. So the 5.6 design of parallel replication imposes constraints on you as a developer. If you want to utilize parallel replication, you have to design your application to use multiple schemas, have non-conflicting transactions as far as possible, etc. With 5.7, you're expecting to just go ahead with your life and let MySQL figure it out, right? That's the goal.
That's very interesting, yeah, because the other thing, like with 5.6, one of the interesting things we had learned was when we turned on parallel replication on a slave, it actually did seem to work out of the box the way we expected, and it sounded like you actually need to enable parallel replication on the master as well, and I'm assuming that might have something to do with how the stuff is grouped in the binary log, but I'm not 100% sure.
Well, this is not my understanding. My understanding is to have parallel replication working, you don't have to enable anything on the master. Group committing on the master will by itself get into the bin log, and then the slave uses that. So I think in recent version of 5.7, the first version of 5.7 didn't have a way to control the group commit size, but now you can. I call that slow down the master, so wait a little on the master to commit more transactions together, so enlarging the size of your groups, and that allows more parallelism on the slave. This is, I think, a new feature from 5.7.5 or something like that. Well, one of my questions, 5.6 has some constraint on parallel replication. You need different schemas. 5.7 removed that constraint, but there's kind of a strong hypothesis that if things commit together on the master, they can be run in parallel on the slave. So is that always true? Is it true that when things commit together on the master, they will not conflict on the slave? Like this is the base of parallel replication in 5.7, and it's a strong hypothesis. So I don't know if everybody agrees with that.
Hi, this is Non again. Now with my connection it works, so I can answer that to Jean-Francois. Yes, if the transactions commit in parallel or are executed in parallel on master side, then that means that they don't have conflicts. So there is no lock contention or anything like that. So they can run in parallel on slave.
Even
so what you are thinking, it's true.
Well, even there's two ways I think to run the transaction on the slave. There is out of order commit and in order commit. I heard that it could happen that in order commit cause some deadlock that needs then to be rolled back by parallel replication. Is it something that some people have met before?
I'm not getting your question, but you should not have that, because you may have, when you run out of order on slave, you may have a different state that you never had on master.
Mm-hmm.
But even with that, since they were not conflicting, you should be able to commit them in parallel. So the only side effect is that you may have a different state that will never exist, that never exists on master side. But when the parallel applier on slave gets to a consistent point, then it will be in sync with master.
So I just want to chime in and say I pasted some links and the name of the settings to control binary log group commit in 5.7. But continue on. I didn't want to interrupt.
It's too late. The interruptions happened. I was actually going to ask if anyone wanted to give kind of a super quick overview of what's actually going on in replication. Because we're talking about group commit and kind of putting these statements together, or packaging them. So I think everyone here knows, but just to clarify for folks who don't understand that, the first naive thought is you have a master, you have a slave, and then the slave just connects and downloads statements. But there's actually some additional stuff happening here where things are being kind of grouped in chunks and sent down to the slave. And does anyone want to just talk about that super quick? What's actually going on in the master and the slave interaction there?
That's kind of that's too generic, right?
Morgan has a really nice blog post about that. So I think in MySQL 5.5, if I reformulate what Morgan put it in his blog post, every transaction needs to be put in the bin log one at a time, and that was before group commit. But that was not efficient because every transaction needed to be written one after the other, and they were serialized in the bin log. 5.6 introduced group committing, so many transactions can run at the same time, and then they are grouped together into a single write operation in the binary log. So they commit together at that time, and if they commit together, it means that they are not holding conflicting logs. And so this is an optimization in 5.6 to increase the throughput of writing in the bin log. And 5.7 uses this group commit information. So 5.7 add a new thing in the bin log, which is the information about those transactions, those three transactions belong to the same group. They commit together, so a slave can run those transactions in parallel. So it's kind of hard to do that without an image or a schema. I don't have a schema of that myself.
That's okay. So I think I have a link. I just kind of showed it off on the screen real quick from the blog post that Morgan did write about this with a few small images. So that'll definitely be in the show notes for folks to review, just to kind of see what's going on there. But yeah, so parallel replication, we're actually starting to unblock this thing where you don't need to have different schemas to actually get the benefit. And that, I mean, for me, that was kind of the big win. Was our sharded environment, each schema is a different shard, so it would have worked out because we co-locate multiple shards on a single instance. So we could have gotten some more speed there. But being able to actually get it for things so that you don't have to have it across multiple schemas is also just another huge win. And I'm actually more interested if there's any performance numbers or anything that kind of show the difference in replication catch-up time, replication speed. And I guess the other one is also just kind of operationally, what's that going to look like to someone, if you run show slave status? How do you interpret that to know if things are working correctly or not?
Well, my experience with show slave status, it's exactly the same thing because everything's happened under the hood. What might happen is when you do a stop slave, because there's many transactions happening in parallel, there will be more wait because it's not you don't need to wait for a single transaction to happen. Maybe there are 5 transactions running at the same time. So the 5 transaction needs to be rolled back or committed before the slave can stop. So a stop slave is a little slower. But show slave status by itself, especially when you have in-order commit, I'll come back on that. If you have in-order commit, the notion of position is the same. You have a single position and you commit in order your transaction. This is actually new from 5.7.5, I think. Before 5.7.5, you had only out-of-order commit. So maybe you start 5 transactions one after the other, and maybe this one is a shorter transaction. So this one is done before the 2 others. So this one will commit before, and that out-of-order commit can generate temporary hole in GTIDs. So if you check very aggressively your GTID state. You might see temporary all if you have out of order commit, which is not the case with in order commit. So for me, show slave status is the same thing, with or without parallel replication.
Yeah, so something that Morgan had mentioned in chat, though, so when you look at show slave status, though, things like seconds behind master, you know, what does that value mean to you as an operator now? How much can you trust it? Is that, I mean, I believe it's, you know, it's the oldest statement that hasn't yet been executed, but how does that kind of look, especially for shops that may build a dependency in their application to interrogate the state of seconds behind master before making a decision to do a read on a read-only slave or something?
I think it's just less granular than you would be used to, but the second behind master is taken from the timestamp issued on the binary logs. So, you know, if it's a group commit, that just means that each entry in the binary log may contain more transactions than you're used to, but effectively, so like Jean-François said, if you're going to stop slaving, it's going to take a bit longer, so you're losing granularity, but the seconds behind master just means how far I am in running the current binary log entry as compared to when that entry was written or supposed to have been executed if the world was perfect. But otherwise, it just means the same thing.
That should also impact the way heartbeats work then.
Well, I personally never trusted second behind master. I more trust heartbeat. And heartbeat is actually an interesting situation in parallel replication. Again, in out of order commit. Let's suppose that transaction here is a heartbeat, and a heartbeat will be a really, really small transaction. The transaction before might be much longer. So you might have a heartbeat that will commit on your slave before a longer transaction, and at that point the heartbeat is visible on the slave, but the previous transaction is not. And I was really, really happy when Oracle introduced in order commit explicitly for that, because I don't want that heartbeat to be visible if that transaction doesn't commit, because it doesn't make any sense on a consistency point of view. So out of order commit was scaring me a little, but now that we have in order commit, I'm much happy. I would really like that to work also without binary logs enabled on the slave, but I think it's coming. Because now in order commit, you need binary logs on the slave.
But Jean-François, just one note about the heartbeat. So the heartbeat doesn't reach the SQL thread, so it doesn't have any impact on discussion.
I'm talking more about PT heartbeat than the heartbeat in the slave protocol.
Okay.
Yeah, we're just talking about injecting the current timestamp on the master.
And about injecting transaction, you can inject transaction on your master to have a more accurate view on the lag, and you can also inject transaction on the master to have a synchronization point on the slave, and I know applications that are doing that, that are inserting a row in a table on the master, and to avoid reading from the master, they pull a slave aggressively for when this will happen, when this row arrives on the slave, and then causality has been established between a write on the master and a read on the slave, and now the slave can be trusted. And I was really afraid that this would break with out-of-order parallel replication, and with in-order parallel replication, I think this is much safer.
I have one question. Is it possible that it will actually slow things down in certain situations? So let's say you got 5 threads. You got 1 long-running transaction and 4 short ones. Now, the 4 short ones go quickly and all have to wait on the long one to finish. by the time it actually has to do a commit, it has to do more work because it has to include the 4 smaller ones as well. Does that make sense?
Well, those 4 transactions would have commit together on the master. If they're executed in parallel on the slave, they would have commit at the same time on the master. In that situation, let's suppose the big transaction is costing 10 milliseconds and the 4 small are costing 1 millisecond. Instead of taking 14, so 1 times 10 plus 4 times 4, instead of taking 14 milliseconds on the slave, it will take 10 milliseconds. There's still a small win here, theoretically.
Well, but because they have to do it in order, that means that the final commit for the group has to happen after the longest running transaction actually commits, right? There's kind of a group commit happening after the individual ones. Or
well,
am I understanding that wrong?
Well, if your long transaction is the first one, let's say this transaction takes 10 milliseconds, and the 3 next are taking only 1 millisecond. So in order parallel replication, we will wait for this one before committing everything, because those must commit after this one. So those 3 will not commit before this one is done. So this would be in order parallel replication. Out of order, those 3 would commit as early as they're done.
So I have a question on that as well then. So just operationally then, you're running something like PT Heartbeat, you have out of order commit. I mean, what is the order of magnitude in which you could see, I almost want to say drift with your heartbeat statements coming through? Like, is it a matter of, like, you know, the timing information that you have is actually off by seconds, or is it on the order of milliseconds still?
Well, it depends on how long this transaction will take. If this transaction is taking 10 seconds because it's a huge transaction, you will see the transaction before here that will be visible for 10 seconds before this transaction happens. So if all the transactions are small, there's no problem. But as soon as there's a big transaction, you might have a surprise. And well, big transaction will be a big problem for the pipeline, for the parallel replication pipeline, because if you have a lot of small transaction and a few bigger one, the big transaction become your outlier in the pipeline, and those big transactions must be broken in smaller one to make parallel replication work efficiently.
Got it. So do folks have? Oh, sorry.
That I'm observing in my test. I'm doing tests with parallel replication on production workload, and I don't get very good speed up because I'm having big transaction in my transaction mix.
Okay, I'd actually be really interested if you get a chance to blog or write up some of the information you captured from this, just how that looks.
It's coming.
So do folks have anything else they want to touch on with multi-threaded replication? It sounds like Nuno's stuff is kind of working, so we could probably go back and start doing the group replication presentation. Anyone? Okay, go ahead and take it away, Nuno, if you want to get a screen share going, and okay. We'll put you on.
Yes, I'm just going to share the screen again. See if now it works. Okay, going again through the agenda. So I have 5 topics here, and let's go through them. First one, what is group replication? In one sentence, multi-master replication is a multi-master update everywhere application plugin for MySQL with built-in automatic switch recovery, conflict detection, and group membership. So, which is a big sentence. So, what does this plugin do for the user? So, it removes the need for handling server failover. It's built in. It provides fault tolerance. It enables update everywhere setups. It also automates group reconfiguration. So, machines crashing, machine joining, machines leaving. It's all fully integrated. It is implemented using a replicated database state machine. and provides a dependable replicated database. So a few more details about this. If you have questions, please do ask. Interrupt me anytime you want. So the simple picture that we can see is that we have a group of servers on this case 5, and clients can connect to each other to each one and do writes, which now is impossible with asynchronous replication. So a more few details. So replication is built in on MySQL technology, so it's proven and it's working for many years. It shares many of MySQL replication components, but now with a multi-master approach to replication. It has an interesting architecture, so our plugin registers as listener to server events. It reuses the capture procedure that already exists for semi-sync, for instance. It is decoupled from some server core, and it provides further decoupling from the communication infrastructure. So we are like man in the middle from the server and the communication. It is built on reusable components. We have a layer implementation approach, and we are interface-driven development. So we are trying to get out of the core even more. A few more details. It provides distributed server recovery. So when a server joins the group, it will automatically synchronize with the others. So no need for at least a full sync before joining the group. That will be taken care. It's a multi-master update everywhere, so clients can connect to any server and just do stuff. And it has a MySQL InnoDB look and feel. So if you have application running on InnoDB, it should work with no stress, or at least with minimal stress on group replication. And I will explain why minimal stress later. So what are the major building blocks for group replication? So each server has several components. You can see here on the right side the stack. We have the MySQL server, we have the API, we have the replication plugin, and we have the communication API. And then at the bottom layer, we have the communication. So looking to the server layer calls into the plugin through a generic interface. Most of server internals are hidden from the plugin. It is still most because there are stuff that we cannot split, but we'll work more on that on the future. Some of the interfaces are shared with semi-sync. So some of the syncs are already known by people. Plugin interacts with the server through a generic interface. Again, most of the internals are hidden from the plugin, and the binary log is injected into relay log for remote transactions, that is, transactions that originated on different servers. We call local transactions to transactions that are executed on our local server, and remote, which are executed on other servers. Now looking to the plugin layer. The plugin is responsible for maintaining distributed execution context. It must detect conflicts and needs to handle distributed recovery. So it detects membership changes. It has to donate state if needed. It has to collect state if needed. It is also responsible for receiving and handling transactions from other replicas, sending transactions to other replicas, and also decide the fate of ongoing transactions. So if a conflict is detected, transactions must abort to avoid problems. Looking to the communication API and also the bindings. So this is abstracting the underlying communication system from the plugin itself, and is mapping the interface to a specific communication toolkit. Currently, we are using coercing binding or MySQL group replication. And now looking to the complete stack. I'm presenting this really fast because I want you to make questions, so I'm trying to speed up this. So this is the complete stack. We now can see a zoom on the server and how the components are split and organized on the server. So you can see that marketing is done through performance schema tables, and those are on server side. We have the capture, lifecycle, and the player APIs. We have the capture, conflict handler, apply, and recovery components. We have our replication protocol. Then we have the group communication API, group communication binding, core sync, and then the network. And also InnoDB, it's how we use and where we have the state. Some considerations about group replication. So it only supports InnoDB, so we need a transactional engine so that replication can work. Concurrent and DDL is not yet supported, so this is future work for the future to be done. A primary key is required on every table. This is mandatory for the conflict detection. We require that global transaction identifiers must be turned on, so this depends on GTIDs. And this is where the behavior changes from the regular replication. We have optimistic execution. So transactions may abort on commit due to conflicts with concurrent transactions on different servers. And this is where the behavior is different from what we know now. Also, we have, this is due to core sync binding, we have limited transaction payload size. So we have some pitfalls here, but they will also disappear in the future. And more three things to say about some considerations. So if we have a workload with hotspots, then that will lead to higher abort rates. So if we know that two hotspots exist, they should be sent to the same server so that it can be sequentialized through locks. So they will have a bigger delay, but then we don't have a abort rate. So we have a trade-off here. This is, of course, better suited for low latency and high bandwidth network, so this is meant for local area network. Going to wide area network, this is a different bit game, and we need more things to be done to have a solution for wide area. And also, large transactions are more likely to exhibit higher conflict likelihood. So if a transaction takes a long time to be executed, it may be aborted by a small transaction that may conflict and make the transaction right side of the big transaction obsolete. So we may have here, this is again related with the hotspots, but now with transaction duration and not transaction conflicts and tuples. I'm just reading here some of the comments.
Oh yeah, sorry about that. I was actually waiting to find a breaking point where I could start asking you a few questions. But actually on like the slide before, maybe two before that, I was curious about the performance schema image that you had and just mentioning it. It seems like so you're going to be exporting some sort of metrics that can be interrogated through performance schema. And I was just curious what that would look like, trying to see what the state of this plugin while it's running is, what kind of data you can get.
Yes, we have three types of data here. We have the configuration data, how the group is configured, and then we have status and status. So we have the membership of the group, so what are the members and how we can reach them for third-party solutions, for instance. And then we have status, so messages per second, and which are the how many conflicts were detected, how many transactions were applied, and things like that. I don't know now in full detail the tables, but you can also see them on the last release. That was released on last Oracle Open World. They are there also. And if you go to MySQL iAbility blog, they are there also.
Okay, sounds good.
After I present, I'll share the blog link.
I would like to interfere for a moment, if you please, and get back up 30,000 feet above, and the question has to be asked. This is comparable to Galera replication, am I correct? It's very similar in essence, right? Or it's a competing technology.
Yes,
so
the
far,
theoretical.
Yes.
Yes, the theory behind those solutions, they are very similar. I don't know
Okay.
for sure about the implementation, but the theory behind is similar.
Okay. So in general, this is a replacement for Galera that comes would eventually, hopefully, come right out of the box with MySQL. Do you have like, just a general overview of, so it's similarly to Galera, it's an optimistic implementation. It's something that you would be able to work active at all times, in order commits. What do we expect in general from this?
Yes, this is the DBSM approach for replicated database for multi-master. So we'll have always the multi-master mode running. Of course, we have some consideration here. For instance, we need a quorum on the group. So we need a minimum number of machines for this to work properly. If not, the group may block, but this will depend on configuration of the group. But apart from that, yes, you have multi-master and things work, and you are also on. This is always working. Just also a small side note, this is virtually synchronous replication, so this is not active. So when you commit on a server, it may take some time to reach the others, but it will eventually reach. So people must be aware of this. If they want to wait for the transaction to reach all the servers in the group, they will need to wait a little bit more. But as soon as it is committed on a server, it is network consistent. So it will be eventually applied on all the servers of the group.
So something that I also wanted to call out, or maybe just mention in case for folks who might also be watching. So previously we have talked about semi-synchronous replication on here, and just based on what you're discussing right now, so this is actually different than semi-synchronous replication because this is solving a problem of spreading writes across multiple machines, not just having guarantees for your reads. Is that correct?
Yes. So on semi-sync, it's only one-to-one or one-to-n. This is end-to-end, so it's a multi-master approach. That's why you need to also control the conflict.
Cool.
And
Thank you.
that's why we have the transaction abort also.
Okay, and I will also like to chime in again, and we will expect, since you're using group commit, etc., and you're relying on normal replication, then we can expect all the benefits that will come from normal replication, like parallel or etc., etc., etc. So this is also a parallelizing replication, right?
Yes, it can be parallelized on remote applier. About the group commit, it's not that so easy because we need to certify the transaction. So it will take. We'll need to spend a few more milliseconds on the network before we can group commit them. So we need to pay some time so that we can ensure that it is network consistent. So you cannot expect that we'll group 10 transactions like we do now on regular replication. At least that for now won't happen.
So I guess another thing is, what's kind of the upper boundary on the number of masters you can have in the topology for this? Because it looks like they all kind of put up a system that serves the events that they have coming in, or the transactions, and exchange those. And so like with MySQL currently, there's that kind of unwritten rule, like 10 slaves, you might be pushing it. Is there kind of a similar thing here with, when you have multi-master replication going between these, like, you don't want more than 10 nodes participating in serving write traffic? Is there some sort of limitation like that, or performance numbers to indicate that?
Yes, there are numbers. I cannot disclose them yet because we don't have a release product. But yes, don't expect to have hundreds of members. No, it should be a number of dozens, not hundreds.
Okay.
Not because of the number of slaves, but because of the round trips needed for the group communication.
I think the important qualifier there it's probably been mentioned already, is that every member of this group has all of the data. It doesn't have a subset of the data. So that's a limiting factor in itself.
Morgan, can you
So are
repeat
there any
please?
plans to address the wide area network issues? I know that's kind of implicit in this approach that you have a problem with that overhead is kind of the limiting factor, but are there any plans in that direction?
I cannot disclose the plans, like you know. Right.
Darn. Okay. Well, unless there's other questions, I guess why don't we let you go ahead and get through the rest of this, and we can barrage you with a couple more.
Okay. So let's go to the summary. So this is kind of trendy. So this is a great technology for deployments where elasticity is a requirement, such as cloud-based infrastructures. It is integrated with the server core through a well-defined API. It works with JTIDs and row-based application. It also is integrated with from schema tables for monitoring. Also, it is autonomic and operation friendly, so it is self-hailing, no admin overhead for handling server failovers. It provides fault tolerance, enables multi-master split everywhere, and the dependent on MySQL service. And as you may expect, this is just a short presentation of it. It does more than that. So to explain it in more time, so please give it a try on the large release. See our blog posts that Morgan already pasted the link, and give some feedback, please. And now for some more questions. Okay,
on the performance point of view, what can we expect from a cluster like this? Is it more efficient than replication or less efficient than replication? And what will be the bottleneck compared to standard replication? And can I put more data through replication but less write than on a single master? This would be what I would expect, but maybe you can share more information about it.
It will depend on your workload and how you split the writes, because if you do let's say optimal split of the data, you can get more performance than regular replication because you are splitting the write loads for different servers. But if you get hotspots, then you'll notice that the performance will degrade. So it is highly dependable on the workload and how you split the writes are done. So you may have good performance or a really bad performance.
Okay.
So something else you had in one of the limitations was that there's a limited transaction payload size. I'm just curious, what's the default of that, and what are the configurable values for it?
So that is not configurable by MySQL replication. It depends on our replication layer, which currently it's CoreSync. So we don't have control of it. So for now we just have to live with that. So if the method is bigger than the maximum payload, the transaction will be aborted.
Okay.
But this solution is not meant for really long transactions, because those will be aborted by all small transactions that will happen in parallel.
Yeah, that's why I was asking, because in our environment, normally you have those nice, couple queries. They're done in a couple milliseconds, maybe a few seconds. But once in a while, there's a couple, minutes, and sometimes we have hour-long transactions that sneak into the system. They don't have a lot of statements in them. They're actually done in 2 or 3 minutes. It's just they're open for a long time for some inefficient operation. I was just curious what that would look like, but yeah.
Yes, it won't work. Let's be honest.
That sounds good.
No, because the transaction's duration must be equally distributed. So if they are, so that they have the same hypothesis to be committed. If you have one big one and 1,000 short, 1,000 will pass, the big one will be aborted.
So the other thing was hotspotting was mentioned, and Morgan had said counters were one of the examples. What other kind of data hotspotting issues could be encountered when using this kind of system?
It depends on the workload of the application. So if you have a tuple that is a really hotspot, you need to send that to always to the same server. If you send that tuple to different servers, they will abort and they will conflict with each other.
Okay. Is it possible to do some of the other, sneaky workarounds with things so again, counters are a really good example where you can have hotspotting on a single record on a single server, and that's already very inefficient. And so one of the short, easy solutions is to mod 10 a counter across multiple records, or mod 100, so that you're writing to multiple different sets of records, and then when you read it, you aggregate those. And if you did a method like that, I'm assuming it's then safer to actually send it to more of the nodes instead of having to focus on a single one. Is that right?
Yes, no. If you split the writes, then you are okay.
Cool.
So if you can control that, you are safe with that. Then it's not an hotspot.
Nuno, just to clarify the thing, so let's say that I had a counter. I hash that counter and I pick a server that I always go to. But if I modified that hotspot row, that counter, more than once per round trip time, that would still be a problem. Picking the one server wouldn't be good enough because it has to certify that right. Is that correct?
Yes, if your throughput is higher than the throughput that certification can handle, yes, it's a problem.
Well, in that situation, you would end up with a row log in InnoDB. So it's
makes sense.
So during your round trip time, you would keep that row log on InnoDB. So throughput would be reduced. So even hashing to the same node, you still need the mod 10 solution to make sure that you don't keep the row log for too long.
Yes, yes. But if it is executed on the same, yes, it will be delayed, but not abort yet. Yes. Yes. When using replication, you need to be aware of the network penalty that you need for certification.
Yeah, I think commit will take a little longer because of certification.
Yes, it takes a little.
The latency of the commits will be a little longer.
Yes, but we also need to remember that when the transaction is committed, it is network consistency, so
yes.
It will never be lost. So it's a trade-off. You can lose a master and lose the data, or you can have replication and you never lose the data.
For me, both group replication and parallel replication introduce an interesting shift in application design. In MySQL 5.5, commits were expensive, so we were trying to avoid commits and do big transactions. And with MySQL 5.7 and group replication, now this changes. We must hunt big transaction because big transaction block parallel replication pipeline and introduce conflict in group replication. So it's kind of a shift, and it will take time to modify all the application to fully take advantage of both parallel replication and group replication. And this will be a lot of work for the developers, I think.
Yeah,
yes, but on the other hand, it's the more natural way to do it because a developer on its, and developer on their own would issue short transactions, right? They will not look for optimizations of aggregating stuff, etc. It's the most natural thing to do.
Well, sadly, those optimizations are already existing, especially for application that has been developed for MySQL 5.5 or before. And now we will to take advantage of all our cores. and of group replication, we will just shift on another way of developing. I think this is important to notice and begin to adapt right away to fully take advantage of all that. So we often talk about in place, we just replace. We improve the technology and everything should work fine. Well, yes, it should, but to fully take advantage of those new technology, a few things will need to be changed in application.
Well, it's easy. You just go back to when you started building the optimization and delete those lines of code, and then the problem is, you get to leverage it again, right?
Yes, change the flag, optimize false, right?
Exactly, yeah.
Jeff, you sound like management material to me.
Dude, I got this down. So another question that I did have, so if you're running group replication, in a single site, and I have another data center thousands of miles away that I want to also be replicating this data to. So since it's a plugin and it sounds pretty well decoupled from a lot of the other things in the server, I'm assuming I could probably grab one of the nodes that's in a group replication topology and set that up to just do normal MySQL replication to a much farther away location. Is that correct, or is there some other special thing you would have to do?
It's correct. It will work out of the box.
Okay, so
either way, you can replicate from a group to a node, or from the server, or from a server to a group. Either way, it will work.
Okay. I have a question as well. Nuno, we were talking about the transaction size and things like that. And I was thinking why we were grouping bigger transactions was to avoid F-syncs. Do you think that you'll encourage people to not have local durability now that they have network durability? So will you turn off things like sync bin log and InnoDB flush logger to your X commit equals 1 because they have the ability to survive from other nodes having the data?
Yes, we are already thought on that, but we don't have numbers to justify that. But yes, once we have network consistency, you can start to decouple some stuff from the server, yes.
That's going to be awesome.
Especially start to don't do F-syncs, for instance.
So we got about 2 minutes left. I just want to give everyone a chance to get last thoughts in before I kind of listen for topics for the next time so we can get wrapped up. So any other kind of last thoughts around group replication or last questions? It's always silent when I ask this at the end.
Just binlog group replication, just make a subtitle, just showing and telling that this is a synchronous replication algorithm, because for me, when I first heard about binlog replication, it took a few slides before I realized what this is about. So just think about it.
That's kind of contested if it is, though. It's virtually synchronous. It's not synchronous.
Yes, but I understand the comment because many people confuse that. They thought as multi-master as synchronous replication, and that's not true. But we are not advertising that it's like that. So I'm okay.
Okay. Alrighty. So I guess that is going to be a wrap for today. Just real quick, what kind of stuff do people want to talk about at the next DB Hangouts, if anything? Could probably spend a little time talking about GTIDs. We always talk about GTIDs now as operators.
I'd like to talk about recognizing a failover scenario. I'm looking into such things right now, and there's a lot of edge cases and weird cases where you would either declare, I need to fail over, and could be wrong about that, or vice versa. So I think that would be nice.
Okay, yeah, making the decision of is it safe to do it, or
exactly.
The other one, is it safe to kill 9 the server with the stall that it currently has?
Right.
Okay. I also want to talk about maybe some older weird bugs that have come up. My my group, we actually had the joy of encountering a truncate table bug recently that was in the same vein as the drop table bug that used to be around before InnoDB lazy drop table had worked its way through. So maybe just kind of talking about old or weird bugs like that.
I read about that bug. So it doesn't affect 5.7.
Yeah, that's what I'm
example.
told. Everyone's asking me if it's fixed in 5.6, and I'm like, nope. Mark Leith said it was fixed in 5.7. But what else would folks be interested in talking about? Sean Frong? Nothing? Pim? Anything?
Now the failover topic itself sounds like an awesome topic to me. So, and I think
Cool.
that could easily fill an hour.
Okay. Well, all right. I guess in that case, we're probably a wrap for today. Nuno, thank you so much for coming today and giving the presentation on group replication and kind of telling us about what it was, and also answering questions about multi-threaded replication. And you're welcome to join these anytime in the future. It's open to anybody. We'd love to have you come and answer questions and kind of just debate things with us.
Okay, try to join on one more session, and that welcome you for the invitation, and that's the usual thing I usually do.
Cool. All right. Well, beyond that, I guess we're a wrap for today. Thanks very much to everyone who came and participated, and we'll see you all in 2 weeks. Ciao, guys.
Thank you, guys.
Thanks,
Thank you.
everyone. Goodbye.
Bye.